Good day. So this is my final project for our logic circuits and theory. So here we have a given problem. So that is our given problem. And so with that, we have we have in order for us to make an equation out of that equation, first we're going to make a truth table. So we have five variables. So meaning we need to have how many combinations. So we have formula of 2n where n is our how to the number of variables. So 2 to the exponent of 5. So we have 32 combinations. So expectedly we will have 32 combinations in our truth table. But in our for letter A, so if for our letter A, it is said that write an equation, design and develop a circuit for the output Y if we want Y to be 1 if the flow rate is less than 30 gallons per minute. So these are the conditions. So all the digits are 0 if less than 10 gallons per minute. 1 first digit if is at least 10 gallons per minute or greater than or equals to 10 gallons per minute. Second and the second digit are 1 if that at least 20 gallons per minute or greater than or equal to 20 gallons per minute. Next is the first and second and third digit are 1 if greater than or equal to 30 gallons per minute or at least 30 gallons per minute, and so on. So in letter A, it's only we're going to make an equation if you want Y to be 1 if the flow rate is less than 30 gallons per minute. So the one is being covered are this 1, 2, and 3. So we have here our truth table. Estas immediatong truth table. So 16 zeros and 16 ones. So ang ni ang ni ang ni correct na sa atong condition are these three. So this one, and this one. So all the digits are zeros and one zeros. One first digit are 1 and the rest are zeros. So we'll have an output of Y is equals to 1. And next is we have first and second digit are 1, then we can have an output of Y if all the rest are 0. So mean terms, so not A, not B, not C, not D, and not E. So in order for us to get Y as an one as an output, here we have A, not B, not C, not D, not E. In order for us to get one output, and the last is A, B, not C, not D, not E. In order for us to get our Y equals to 1 as an output. So without mean terms, I simplified it already, and we come up with this schematic diagram. Here we come up with this schematic diagram with the equation C bar D bar E bar A plus C bar D bar E bar D bar. So with this equation, we make a schematic diagram. So we will need to have a 4 input AND gates, two 4 input AND gates, and one OR gate. So there are many ways in order for us to make a schematic diagram of it. First is that we can make this schematic diagram, one of our schematic diagram that some of us use. So this one. So we can just add two AND gates in order for us to have, we just need to derive this one. The simplified equation was C bar D bar E bar A bar plus C bar D bar E bar D bar. So we just get A and B. So we multiply it with the same as CDE, C bar D bar E bar. So they are the same from the other side. So we just put it in the left side, and and group A plus B bar. So we can come up with this kind of schematic diagram. So the output is also the same as with this schematic diagram. So I use NOR gate and NAND gate in this schematic diagram because I also want to experience using these ICs. So with this schematic diagram, I'm going to put it in our breadboard and let's see let's see if it is correct. So I have now here our breadboard. So this is our deep switch. This is our resistors. This is our inverter. It's SN74S04N. This is our NAND gate, which is 74S00N. This is our NOR gate, 74S02, and this is our OR gate, which is 74L LS32N. So according to our truth table, we need to have four zeros, four digit zeros, for input zeros A, B, C, D, and E in order for us to have an outcome of Y1 equals to 1 as an output. So we can see here clearly that the LED lights turn on, so it's correct. Next is the first digit should be 1. The first bit, should be 1. And the remaining are zeros. We can have a Y equals to 1 output. So we just turn this one. So our 1 is A, B, C, D, and E. So correct. And next is our first and second bit are 1 and the rest are 0. So we can also have a Y equals to 1 output. So correct. Then if you're going to turn on, if the first, second, and third digit to be turned on, then it should turn off. Because the condition stated clearly below that if you want Y to be 1, if the flow rate is less than 30 gallons per minute. That's all. Thank you. Good day. So this is my final project for logic circuits and theory, letter B. So the first problem was all about Y. If you want Y to be 1, if the flow rate is less than 30 gallons per minute. But in this problem, in the condition that we're going to make Z to be 1 if the flow rate is at least 20 gallons per minute but less than 30 gallons per minute. So with that given problem earlier, we will look back from how many variables we have. So we have 5 variables. So in order for us to get number of combinations, so 2 to the exponent of n, 2 to the exponent of 5. So we have 32 combinations. So in letter B, same as in letter A, we have 32 combinations. With that, we're going to make a truth table having 16 zeros and 16 ones because 32 divided by 2 is 16. So we have here 16 zeros and 16 ones, 8 zeros, 8 ones, and so on. So in this truth table, we have conditions. So all bits are 0 if less than 10 gallons per minute. First bit is 1 and the rest are 0 if greater or equal to 10 gallons per minute or at least 10 gallons per minute. The third condition is the first and second bit are 1 and the remaining are 0 if at least 20 gallons per minute or greater or equal to 20 gallons per minute. Next is first and second bit are 1 if the rest are zeros if greater than or equal to 30 gallons per minute or at least 30 gallons per minute. Next is first, second, third, and fourth bit are 1 and the remaining 1 bit is 0 if it is greater or equal to 40 gallons per minute or at least 40 gallons per minute, and so on with a 10 gallons gap. So in this condition, we're going to make equation out of this condition by referring to our truth table. So from the problem, as I've said earlier, you're going to write an equation, design, develop a circuit for the Z if you want Z to be 1, if the flow rate is at least 20 gallons per minute but less than 30 gallons per minute. So from our given truth table, the one that quantifies or the one that can the one that fit our conditions and our problem are this one. So the first, because it's said to be less than 20 gallons per minute, so at least 20 gallons per minute, I mean, so greater or equal to 20 gallons per minute but less than 30 gallons per minute. So greater or equal to 30 gallons per minute, it's 50 gallons per minute, 50 gallons per minute. And greater or equal to 40 gallons per minute, but not the last one because it's greater or equal to 50 gallons per minute. So all these conditions must be applied on our truth table. So looking back from our truth table, so our condition is first and second bit are 0, remaining are 0. First and second bit are 1 and the remaining are 0. So this one, so we have an output Z equals to 1. Next, our first, second, and third bit are 1 and the remaining 2 bits are 0. So this one equals to 1. And the first, second, and third bit, fourth are 1 and the last bit is 0. So what Z equals to 1. So from this equation, from this truth table, we're going to make equation having our mean term. So by looking at this, in order for us to get Z equals to 1, so we have A, B, C bar, D bar, E bar, and next is A, B, C, D bar, E bar. That will be equals to Z equals 1, and the last is A, B, C, D, and E bar. So from these mean terms, we can come up with an equation, and we're going to simplify it. So by simplifying, we get this most simplified equation. So we have our most simplified equation is A, B, E bar, C plus A, B, E bar, and D bar. So this is our most simplified equation using 4 input AND gates and 2 4 input AND gates and 1 OR gate. But if we don't have this kind of ICs, we can use some of the ICs that we have, the AND gates and the OR gates. Added all the AND gates, you can also have 4 input AND gates. And also from our previous video, we can also apply on this problem. We're just going to go back one step. So A, B, E bar, C plus D bar. So we can use that equation and we can make a schematic diagram out of it. But in this problem, I'm using NOR and NAND gate in order for me to also see what are the outcomes of these ICs. So from this equation, we're going to we're going to make a schematic diagram. So this is now our schematic diagram. So all the numberings are there, the NAND gates, all the numbering of NAND gates and the NOR gates, OR gates, inverter, and the inputs, resistors, and the LED. So we have a legend at this side. So in this schematic diagram, we're going to put it in our breadboard if our schematic diagram and our equations are true to the condition and to the problem that we're going to answer. So now, we now have our breadboard. So this is our circuit based on the schematic diagram. So we just follow all this numbering so we can come up with this circuit. So reviewing by reviewing our materials, so we have a 6 gang dip switch. This is our inverter. It's SO4N, and our NAND gate issue, which is 74LS00N, our NOR gate is 74LS02 and our OR gate is SN74LS32N. So if this circuit will coincide in our truth table, so our truth table, our equation, and all our processes are correct. So according to this truth table, according to this condition, we can have an output z equals to 1 if first and second bit are 1 and the rest are 0. So my first bit is A, B, and so on. So C is the third bit, D is the fourth bit, E is the fifth bit. So we just need to turn on A and B. 1 and 2. So the LED light turn on. So that's correct for our first condition. The second condition is z equals to 1 if the first, second, and third bit are 1 and D and E are zeros. So we will have a z equals to 1. So this LED light should remain turned on. If I'm going to on this third bit, which is C. Correct. And the last condition is from the first, second, third, and fourth bit are 1 and the last bit are 0. So we can have z equals to 1. So that LED light should remain turned on again. So that's correct. So to see if our breadboard is correct, so in this part it is not included that all the bits are 1. So this LED light should turn off if I'm going to turn on letter E or the fifth bit. So this LED light should turn off. So that's it. Let's turn it back off. So I think that's all. Thank you.